what we're going to do is we're going to move on with Chapter 1. These are the skills, again, that we're working on with Chapter 1. Definitions, distance and midpoint formulas, using a compass and a straight edge, area and perimeter, and classifying polygons. Now, Chapter 1, Section 4, we're measuring and classifying angles. And that would, we're going to be looking at 1C, a little bit of 1A with this chapter. And so first of all, angles. What are angles? Well, angles are formed by two rays with the same endpoint. So if I take a very close look at this, you're going to notice that I have one ray that starts here and goes out. You'll notice the little arrow on the end. And the other one starts the same place and then it goes out in the other direction. A couple of things you need to know. The sides are those rays, and the vertex is where those two rays meet. It's kind of like the sun and then the rays that go out. Now, let's take a look at naming angles. One way of naming an angle is if I'm given a letter, I can say angle A. Notice that the little symbol of an angle doesn't have little arrows on it. And the letter that I put has a capital letter. The second example would be if there's a number inside, and we can do a little angle symbol and then the number 3. Now, when you do this on an exam or any kind of an example, if they don't give you a number, don't just put a bunch of numbers in there and label them yourself, unless they don't have letters associated with the angle. So like, for example, on this example, you wouldn't put like a number 4 in there and say angle 4. I would want you to label this a little bit differently. So generally, if they give you 3 points with the angle, one way of labeling it is MTX. So again, what I did is I went MTX. Or I could label it XTM. That's another way of labeling it. So angle XTM. Notice that the letter T is in the middle, and that's on purpose. The reason why they do that is that denotes the vertex. The vertex is always in the middle when you have 3 letters. Let's move on. It says when you see this, and you'll see it sometimes, we read it as the measure of angle A. That little M in front is measure, and then that symbol is angle, and then of course the capital A is the equal sign, and it's 80 degrees. So that's how you read it. When we measure angles, a couple of tips. First of all, what you're going to do is you're going to line up your protractor. This is where the vertex goes. And then you line up the side of the angle on this line. And then you see where it crosses. So like if it crosses here, notice that would be about, 73 degrees. It wouldn't be 117 degrees because you'll notice that this is an acute angle. It's less than 90 degrees. Another way of looking at it is, again, I have my vertex here. Sometimes you can line it up this way with one of the rays there, and let's say I go here. Okay, this would be an obtuse angle because it's more than 90 degrees. And so we would say 120 degrees as opposed to 60 degrees. So that's kind of the idea behind measuring your angles. So the main idea is lining the vertex up where it is right there, taking the line segment, so this line segment right here, that would be lined up right here. And then this piece right here would fall somewhere out here on the protractor. If you need me to show you in class, I'd be more than happy to help you. And then also on the other angle, this is where the vertex goes, and you'd literally turn your paper so that you can line up the different parts on the protractor. All right, let's move on. Classifying angles. This angle, you'll notice, is less than 90 degrees because, again, the 90-degree angle would fall like this. And so because it's less than 90, I'm going to call it acute. Think of it as a cute little angle. Again, it's less than 90 degrees. Okay, this angle, generally we don't assume that it's a right angle, but in this instance you can, because you're comparing the different angles. Sometimes this angle will have a little square thing in it. What that means is that it's 90 degrees. We call it a right angle, so think of it as the perfect angle. Everyone wants to be right. Okay, and again, that's 90 degrees, exactly 90 degrees. The next angle you're going to notice is very large. It's more than 90 degrees because, again, the 90 degrees would come up straight like this. And so what we would do is we would say this is obtuse. Oops. And that's more than 90 degrees. And so notice that they're all comparing to that perfect angle, that right angle, which is 90 degrees. And then finally, this is one that students really get messed up on a lot. This is 180 degrees. And think of it as like a straight line. And so they call it a straight angle. And you will see that. It's a complete 180 degree angle. You're going to notice it's an angle too because it has that vertex there. All right, let's move on. Estimate the measure of these angles and then classify them. Again, it's estimation. You never can assume anything is like 90 degrees, but in this instance, you can because it's asking you to estimate it. So if I take a look at the first one, this one I would estimate that at 90 degrees, and I would say that's a right angle. This next one, if you think about it, if this is a 90 degree angle going like this, it looks like it's half. So I would say this one is a 45 degree angle, and of course it's acute because it's a cute little angle. It's less than 90 degrees. This angle, again, if you think of it based to that 90 degree angle, that perfect angle, this is considered an obtuse. And so if I look at it in relation to the 90 degree angle, it looks like it's 90 degrees and then another half of a 90 degree angle. So I would say that's approximately 135 degrees. And again, with estimation, as long as you're in the right ballpark within, 5 degrees, I would say you'd be fine. All right, let's take a look at the angle addition postulate. Now, the past couple of lessons, we talked about segment addition. So if you remember with segment addition, we said that if I have a segment like this, and let's call it A, B, C, we would say that the angle line segment AB plus line segment BC equals the whole line segment, which is AC. It's kind of like duh. If I take this piece and I add this piece, it's going to give you the whole piece. Okay, angle addition is very similar to that. And so what it is first of all, we're going to draw a ray like this. And what it says is RST right here. This is RST. That whole thing is equal to, it says RSP. Here's RSP, this piece right here. And, oops, I want a different color. Let's do this one. PST, which is this right here. So it's saying that orange angle and that pinkish purple angle equals that whole green angle. And so I'm adding those pieces together to get a whole angle. Now, let's take that idea, and again, you're going to be seeing this a lot. You're going to see segment addition a lot. You're going to see angle addition a lot. So try to make note of that somewhere, that these are important postulates that you're going to use in proofs. So let's take a look at this example. It says, find the measure of the smaller angle. So I'm going to take a look at this. I'm going to take this first angle right here, and I'm going to go x plus 1. And then what I'm going to do is I'm going to take this next angle, which is 2x plus 2, and I'm going to set it equal to 90 degrees. And the reason why I am is because of that little square thing. That tells me that I'm at 90. Now again, when we solve for this, we're going to combine like terms. So I've got 2x terms there, so I've got 3x plus 1 plus 2 is 3, and that equals 90 degrees. All right, then what I'm going to do is subtract my 3, so 3x gives me 87. I divide by 3, x ends up giving me 29 degrees. Now this is where a lot of students struggle. They say, oh, I found x, I'm all done, I'm at 29 degrees. Make sure you go back to the original problem because it doesn't say to solve for x, it asks you to find the measure of the smaller angle. So we need to actually find that measure. So what I would do is I would take a look and I'd go, okay, the measure of angle FEG, which is the smaller angle, equals x plus 1. I would write down what the angle you're trying to find and what the expression is. Then what you're going to do is the measure of angle FEG equals, and I'm going to take that 29 degrees. So I'm going to go 29 plus 1. So the measure of angle FEG equals 30 degrees. Notice that I'm using algebra. Notice that I'm naming the angle. I'm not just doing, 29 plus 1 is 30 degrees. I'm not using chicken scratch. I'm not writing things like an elementary student may. I am going above and beyond and making sure that I use algebra, use the expression, those types of things. All right, the next one. This looks kind of funny. I'm not quite sure why it didn't download a little bit better, but it says angles are congruent when they have the same measure. And we talked about that before with angles and side measurements. And so what this is saying is, I have to apologize, it doesn't look real great. It says if I have the measure of angle 1 and that equals the measure of angle 2, then it's saying that angle 1 is congruent to angle 2. And we talked about this before, that when we talk about measure, you'll notice an M here and an M here, we're going to use equality. But when we just have the angles, we're going to use congruence. And we've talked about that before. If you look back, I believe it was in section 2, we talked about that. Now, when we say that angles are congruent, let's say these first two, I'm telling you that they're congruent. There are ways of marking these. One way is using like a 1 hash. So I'm going to depict them as being congruent because they each have the same 1 hash. These, I'm going to say these are congruent, and I'm going to show that they're congruent by 2 hashes. Sometimes you'll see 3 hashes or 4 hashes, depending upon the figure that we're looking at. Let's move on, and it talks about an angle bisector, okay? The key is bisector. That's the key. And it's a ray that divides the angle into 2 angles that are congruent. So if I take a look at this, my bisector is right here. It doesn't always cut it in half. They need to tell you that it's a bisector. And then what that means is that this angle right here is congruent to this angle right here. Notice that I didn't go like this. Notice that I make these a little uneven so you can really see that I'm denoting 2 separate angles. All right, that's it for the chapter. If you have any questions, please feel free to email me, let me know, and then good luck with section 4.